Standardized scores, and in this case we're going to be talking about z-scores, are very cool because a standardized score gives you a transformation of a raw score that is immediately interpretable. In other words, you can look at a standardized score and know just from the standardized score where the raw score fell in the distribution. So let me give you an example. If your friend comes up to you and says, "Hey, I just scored 58 on my test," that doesn't tell you anything, right? You can't know from a raw score how good or bad the score was. You have to know the mean of the distribution, and you have to know the standard deviation of the distribution in order to be able to judge whether or not that raw score of 58 was good or bad. So let's use that as an example. Let's say the raw score we're dealing with is 58, and in the first example, let's say that the mean of the distribution that raw score is from is 30, with a standard deviation of 10. Now, if we calculate the z-score equivalent of 58 for this first example in the distribution where the mean is 30 and the standard deviation is 10, using this formula, we get 58, which is the score, minus the mean, divided by the standard deviation, gives you 28 divided by 10, which equals a z-score of positive 2.8. Now you know from your textbook that a z-score of 2.8 means that the raw score that this z-score came from is 2.8 standard deviations above the mean. That's really good, right? Let's look at our second example. Let's say instead that this raw score of 58 came from a distribution of scores that had a mean of 80 and a standard deviation of 20. Well, in that case, using the same formula, we take 58 minus 80 divided by 20, which equals minus 22 divided by 20, which equals minus 1.1. Well, that's very different. Now we get a z-score of minus 1.1, which means that the raw score of 58, when it came from this distribution with a mean of 80 and a standard deviation of 20, yielded a z-score of minus 1.1, which means that that score was 1.1 standard deviations below the mean, right? So when you calculate a z-score from a raw score, you know immediately where the raw score falls in the distribution.